Good morning.
Today we will learn flow of laminar fluid between two parallel plates. In last lecture we have seen flow of laminar fluid between circular pipe. In this case the shear stress distribution, velocity distribution and the ratio of maximum velocity to average velocity with difference of pressure head for given length of parallel plate are to be calculated. Consider two parallel plates which are placed at a distance of t. A viscous fluid is flowing between these two parallel plates from left to right. Consider a fluid element ABCD which has length delta x, the thickness delta y. This fluid element is situated at a distance of y from bottom plate. This fluid element is shown in the large scale here. It has length delta x, height delta y and thickness inside the board is assumed to be 1. This is the difference. This 1 represents the unity. So the area of the plane AB is delta y into 1 and the area of plane BC is delta x into 1. Now we have to calculate different types of forces acting on this fluid element. First is the pressure. Let's assume pressure acting on plane AB is P and pressure acting on plane BC is P plus dou P by dou X into delta X. Dou P by dou X is nothing but rate of change of pressure in the direction X and we have moved the distance delta X. Pressure force can be calculated by using the formula P, that is pressure into area. So pressure force on AB is pressure multiplied by area of AB, that is nothing but delta y into 1. And similarly on plane DC the pressure acting is this and area is the same, delta y into 1. Let's consider shear stress. Here we are supposed to find out force due to shear stress. On BC tau is the shear stress and as we move away from the lower bottom plate the shear stress experienced by the fluid element goes on increasing as we are leaving the upper side, so that on face AD shear stress will increase by this factor tau plus dou tau by dou y into delta y. Dou tau by dou y is nothing but rate of change of shear stress in the direction y, and as we have moved from face BC to face AD by the distance delta y. So total shear stress on face AD is shown here. Then the shear force can be calculated by using shear stress into area. So on BC shear stress is tau into delta x into 1. On face AB this is the value, that is tau plus dou tau by dou y delta y whole multiplied by area, that is delta x into 1. Thus we have calculated the shear force as well as force due to pressure. In the previous derivation we have seen with zero acceleration summation of all the forces is equal to 0. So adding all the forces, this is the pressure force on AB, this is the pressure force on CD which is in the opposite direction so that it has minus sign. This is the shear force on BC which has negative sign, and this is the shear force on AD which has positive sign because it is in the direction of flow. Addition of all these is equal to 0. After simplifying the equation we will get this equation Cancelling common terms, that is delta x, delta y, we will get equation minus dou p by dou x plus dou tau by dou y is equal to 0. Dou p by dou x is equal to dou tau by dou y. This is equation 1. Now we will start with calculating the velocity distribution. We know that Newton's law of viscosity, tau is equal to mu into dou p by dou y. Putting this into equation 1, we will get this equation. Dou by dou y of mu into du by dy, which will result mu into dou 2 u by dou y square. Making it simplified, dou 2 u by dou y square is equal to 1 by mu dou p by dou x. We have to integrate this. By integrating first time, we will get this equation. Dou u by dou y is equal to 1 by mu dou p by dou x into y plus c1. c1 is the constant of integration. Let's integrate it once again. U is equal to 1 by mu dou p by dou x y square by 2 plus c1y plus c2. This is the equation 3, which contains two constants of integration. C1 and C2 can be found by boundary condition from the figure. In figure, you will observe y is the variable and y has two values. When y is equal to 0 means when this fluid element is at lower bottom plate, then velocity will be 0. And if this y is at the upper side plate, then y is equal to t. At that time also velocity will be 0. Considering first condition, putting y is equal to 0 and u is equal to 0 in equation previous, we will get C2 is equal to 0. Considering this as well as second boundary condition, y is equal to t and u is equal to 0, we will get the value of C1 is equal to minus 1 by mu dou p by dou x t square by 2t, which is nothing but minus 1 by 2 mu dou p by dou x into t. Putting the value of C1 in the equation of u and making the simplification, we will get the final equation of velocity distribution. U is equal to minus 1 by 2 mu dou p by dou x into ty minus y square. And this is the equation for finding out the velocity distribution. In next part, we will see the ratio of maximum velocity to the average velocity. Thank you.